Okay, guys, we have the 2020 question 3. Set 3 equals 2i multiplied by set 2. We get 2i here, and we get set 2, which is minus 2 plus I. We multiply it in. 2 times 2 is minus 4, so that's minus 4i. 2i by I is 2i squared, and 2i squared is 2 times minus 1. Okay, it says in the form a plus bi, so real part first. So that's going to be minus 2 minus 4i. A, B are integers, so minus 2 would be A, and B would be minus 4. Not that you're asked for that, you're just asked to deliver it in this form. Now it wants me to plot Z1, Z2, and Z3 on the following diagram. Z1 is 3 minus 4i, Z2 is minus 2 plus I, and Z3, what we just did a second ago, is minus 2 minus 4i. Okay, let's go for this. So, Z1, 3 across, 4 down. So, Z1 would be located here. Z2, which is minus 2 and 1i. So, minus 2 plus 1i is basically the point minus 2, 1. Minus 2 across, 1 up, and that is your Z2. Your Z3 is minus 2, which is 2 across, and 4i, minus 4i, which is 4 down. So that there is Z3, and you're good to go. Next question. Find the modulus of Z1. Well, Z1 is 3 minus 4i. Modulus means its length from the origin, which is basically the square root of the real part squared plus the imaginary part squared. The real part is 3, and the imaginary part is minus 4. Put all that into the calculator. Hell, we'll do it for you. Squared plus minus 4 squared, 5. So the answer is 5. Now, next one. If Z1 multiplied by Z4 is 29 plus 3i, okay, so there's two ways of doing this. Z4 is a plus bi, and Z1 is 3 minus 4i, and you can do it as a plus bi, which is a plus bi, and that equals 29 plus 3i. We multiply it out. 3 times a is 3a, 3 times b is 3bi, minus 4ai, and then 4i minus 4i times bi is minus 4bi squared. I squared is minus 1. Minus 1 multiplied by minus 4 is plus 4b. Now what we're going to do is we're going to match up the real parts on each side with the imaginary parts on each side. So the 3a and the 4b, they add together to become 29, because these are the numbers that have no i's in them. On the other side, the 3bi and the 4a, so minus 4a plus 3b, that has to equal 3i, which is just 3. Now, if we add downwards, lads, okay, we have a simultaneous equation. I'm going to get rid of the a's. I'm going to get rid of the a's by turning this into a 12a. I'm also going to turn this one into a minus 12a. So you're going to multiply the red equation by, red equation gets multiplied by 4, green equation gets multiplied by 3, and this should work out nicely. We're going to get 12a plus 16b equals 4 times 29, 116. And then the other one is minus 12a plus 9b equals 9. 25b equals 125. and b will equal 5. Sub that back into one of the original equations. I'll choose the red equation. 3a plus 4 times b, 4 times 5 is 20, equals 29. This must mean that 3a must be equal to 9, because 9 plus 20 is 29. This means a equals 9 divided by 3, which is 3. Likewise, b is 125 divided by 5, which is 25. 125 divided by 25, which is 5, alright? So this means my answer is 3 plus 5i. The a value is 3, the b value is 5. A and b are real numbers. Okay, happy days. Now, let's have a look at the next one. Lads, I'm going to do 4b right now. Now, 4b is a power question, just to show you the rules for powers. 2 to the power 3 multiplied by 2 to the power 4 is 2 to the power 7. 2 to the power 3 to the power 4, this is the multiply rule, which you get as 2 to the power of 12. The division rule, 2 to the power of 8 divided by, for argument's sake, 2 to the power of 5. You take away the powers and you get 2 to the power of 3. Okay, that's all you really need for this. Now, generally speaking, they need to have the same base number as each other. So, you have 2 to the power of 9x minus 1. Now, we're going to change 8. You go to your calculator, you press 8, and then you go shift, fact, and it turns into 2 to the power 3. So I've turned 8 into 2 to the power 3. Now they both have the same base number. So as an example, 2 to the power of x equals 2 to the power 7. This would imply that x equals 7. However, if I had 2 to the power of x equals 8 to the power 7, I can no longer say x equals 7 because the base numbers are not the same. So in order to do this question, I needed to turn the base number of 8 into 2 to the power 3. Now I'm going to use this rule here where I multiplied the 3 by the 4. 3 multiplied by 2x is 6x, 2 to the power 6x, 2 to the power 9x minus 1. Now that we know that the base numbers are the same, we can then say that 9x minus 1 equals 6x. Bring the 6x to the other side. 9 minus 6x equals 1. 3x equals 1. And then x equals a third. Okay. So we also did question 3, and we also did 4b. 3 and 4b. Okay. Now, question 7. Patrick buys a new car for 32,000. He trades in his old car and given an allowance of 20 grand by the garage. He borrows the balance of money from the credit union. His monthly repayments over 3 years. So 3 years of months is 3 by 12 is 36 months. How much does Pat pay in total to the credit union for the loan? Well, he's going to pay €443.66. And he's going to do that 36 times. And he pays €15,971.76 to the credit union. Happy days. Show that the amount that Pat repays as a percentage of the amount that he borrows from the credit union is 133.1%, correct to the nearest. So, what did he borrow from the credit union? Well, he had 20,000 from the garage, and that left him €12,000 short. He's €12,000 short. So he took out a loan of 12,000. However, he did pay 15,971.76 for this loan. So if I divide the amount I had paid for the loan divided by the amount I actually borrowed, multiply that by 100, and we're hoping that this comes out as 133%. So here's hoping. There's the fraction. Now we're going to multiply it by 100 to turn it into a percentage. And lo and behold, 133.1%, the nearest decimal. Happy days. Okay, let's move on. A sum of money is invested at R% per annum, compound interest for 3 years. At the end of the 3 years, the value of the investment has increased by 33.1%. Find the value of R. Well, what I like to do when I'm asked with this type of question is I like to make up a number and follow through with it. So the formula for compound interest is your final value equals your initial value multiplied by 1 plus I to the power of t. Okay, so t is 3 years. You have 3 years worth of interest. I is your, if, for example, if the I value was 6%, you'd have to present I as 0.06. And then 1 plus 0.06 will be 1.06. So generally speaking, this number here, which is 1 plus I is generally a number bigger than 1. So we'll just call this x to the power 3. Now what we're going to do is we're going to make up a number. Okay, for argument's sake, we took €1,000. So our loan was €1,000. And at the end of the 3 years, the €1,000 increases by 33.1%. So we get our €1,000 and we increase it by 133.1%. And this increases it by that amount. So it's 1,331 would be the final balance. Now this is done yearly, hence compound interest. So to get the x3 on its own, here's what we're going to do. x3 on its own is 1,331 divided by 1,000, which is 1.331. That equals x cubed. Now there's a button. If we have x squared equals 25, we use the square root button, root 25. But this time it's x cubed. So we're going to use the cube root button, which is 1.331. We're going to cube root 1.331. And what we get is 1.1. Okay. And 1.1. Your x value is 1.1. Now please remember that the x value equals 1 plus I. So 1 plus I is 1.1. This implies that I equals 0.1. And 0.1 in decimal form is actually 10%. So your I value, or technically your R value, is 10%. Quite a difficult question, lads. I suspect a lot of you would find that one particularly difficult. Okay, so that's question B. Now, we're on to C part 1. It is estimated that the value of the car depreciates at a compound rate of 20% per year. Use this percentage to find the value of Pat's car after 3 years. Now, there's a compound interest formula. Your final value equals your initial value equal to 1 minus I to the power of t. The I value is 20%, which is 0.2. So your original price is 32,000. You multiply it by 1, take away 0.2, which is actually 0.8. This means you're basically retaining 80% of your value every year because you're only losing 20% of it. And to the power of 3 years, throw that into the calculator. Long behold, 16,384. Okay, handy out. Let's go for the next one. If Pat's friends Caitlin bought a new car 3 years ago, its value also depreciated by 20% per year. It is now worth 17,920. Find the original value of the car. So in this case, we're not looking for the F value, but we're actually looking for the P value. And once again, we're going to list this equation here. Okay? And what we're going to get is our F value is 17,920. That equals the P value. Now the I, it's still 20%, so it's going to be 1 minus I is 1 minus 0.2, which is 0.8. And we still know that's 3 years. Now we want to get the P value on its own. So see this 0.8 to the power of 3? What you can do is you can divide that. It's multiply on the left which means it's divide on the right. So your 17,920, you divide that by 0.8, so power 3, and you get 35,000. Your p-value is 35,000, which makes this car worth 35,000 new.